sometimes it's nice to be able to replay. Hello, everybody. I haven't met all of you before, which is cool. It's a lot of you. So yeah, Mon and I were thinking we could use this meeting to sync up. We should discuss how much we want, whether we want to have a kind of weekly time. I'm probably fine with that. If so, whether it should be on Zoom or on Zulip, one is okay, although Zulip is sometimes fine for like lighter weight, for more incremental updates. But I figured we could check in on what you all had done and talk about the next steps and how we should stay organized, because I'm feeling a little, one thing that I tend to do is get involved in more than one thing at a time. And so it's important for me at least to have things in a row so I can come back in and figure out where to get my context quickly. But it seems like my impression is, so we had this kind of plan to start refactoring how the compiler was naming and referring to upvars from closures. And I think some of those rename PRs landed. That's my feeling for what happened, right? I'm not sure if there are any PRs that are like in progress. Maybe this one, refactoring the use of
Yes, it's being worked on. We had issue with span because currently if we use capture closures, you only get an upvar ID. Problem with that is there's no way of, well, we couldn't figure out a way right now to get upvars from upvar ID because as I mentioned in the Zulip chat, we're tracking liveness using span.
Yeah, so, I was just pulling up this link. So this is the span you're talking about?
Yes, but if we use upvar closure captures here, instead of getting a list of upvars, we get a list of upvars def ID or upvar IDs, which do not contain span. So we were trying to find, closure captures. That's an upvar ID and not upvar. So we were looking into trying to find a way of getting the exact upvar path through this. But we didn't spend too much time on it yesterday, but the idea is, so that's why I brought up that if you're going to refactor places, might as well wait and see if we will have span there. And yeah.
Okay, I see. I don't think I noticed this distinction. So the upvars mentioned is giving you
HR ID and upvar.
The here ID of the upvar, presumably.
Yes.
And then this is just a span. That's a kind of new type.
I think, yes.
So that's presumably some instance within the closure where it gets used. Mm-hmm. Okay. And we're saying the closure captures doesn't presently give you a span.
Yes. Also, span, if I understand correctly, is just a way for error reporting and such to keep a track of where in code something is coming from, sort of.
That's right. Yeah.
Okay.
Yeah, a span is just like you can think of it as a pair of line and column numbers.
Okay. Yeah, that makes sense. Thank you.
And so, okay, well, I mean, one option would be for that particular problem. Yeah. I'm trying to remember why we set this up this way. I don't think this upvar list, is it used anywhere today?
You can look the PR that's attached because that will show wherever this was refactored. So I can pull it up if you want. Hold on. Or if you go to our fork, it's probably much easier to get a hold of.
I guess we do use it in some places, the closure capture.
Yeah, hold on. And
72591.
Yeah, I'll send a link on the chat.
Okay. So
there. So that's the PR that was merged in. So that has places where it's being used.
I see, yeah, okay. So for this particular problem, I think it makes sense to me. I don't know why. I think we probably want to extend this map to include span information. I don't know why it doesn't now.
Yes,
Might be a good reason.
actually, it might come back to the whole problem with should place contain a span or not, because this is closure capture, and what we want to actually capture is the place. And a place can be like the minimal place can be associated with multiple spans, because we can just have, let's say, foo.x being called in multiple places in the same closure. So
Sure.
the place is the same, but the span might be different. So probably
Right.
have
This
to
is
keep
actually
it.
the same. So it's the same with upvars, right? You can reference a variable multiple times from
Exactly. Yeah.
a given closure. And what we currently do is just kind of store some arbitrary span.
Okay.
Like if you look at that upvars mentioned query,
Yes.
I
Oh,
don't
so
know how.
it chooses one of them basically.
Yeah, I don't know. It's probably either the first or the last one. Those are the two
Okay.
easy.
That
Uh,
makes sense.
and I think we would do the same here. So sort of some representative span. I don't know why we wouldn't, unless the only reason I can think not to do so would be if there's some like, yeah, I think we already have some similar data. So let me show you.
Mhm.
I was going to say if there's like some reason not to have a span in this data
Mhm.
structure. I don't think that's the case, especially given. So currently we have this
Capture map.
upvar capture map. That's not the thing I was looking for. I think closure kind origins is the thing, right? So what this is saying, this is recording. This is in that same struct, and you see it already has a span. What this
Mhm.
field is doing, as it says, is if one of the things we infer, right, is it an FN, a FN mute, or an FN once
Yeah.
closure, and this gives us
Mhm.
a span. Why did we pick what we picked?
Okay.
And
Yeah.
we use that in error reporting. So the purpose of this span is basically the same, right? We want to have a little explanatory information that we can use for error reporting, and maybe we'll remove it. So one of the things Matthew Jasper mentioned in Zulip is that we're actually moving away in general in the compiler from passing around spans,
Mhm.
and we're preferring to pass around the ID of an expression and then have a separate way to say what is the span
Okay.
for an expression given its ID. And the
So
reason for that is mostly incremental. Like if we include the
no,
span information, then if
that
you
makes sense. No,
change the line and column but not anything else, we still have to,
yeah,
that's like a
that
check.
basically means everything needs to be recompiled because
Right.
you added an extra
But,
line or something.
exactly. But that's kind of an orthogonal thing. And, you know, if you, whichever PR lands first, we'll refactor around it.
That's fair.
So, right. So basically, I think what we want to do, it's probably a good opportunity for us to revisit this type anyway,
Uh,
because the type of the upvar list map. Um, in my opinion, this is not a very clear type. Uh,
mhm.
I think we might want to replace the, instead of having the value be upvar ID,
Mhm.
it might be something like, well, first of all, were we going to rename this anyway?
Uh,
Capture map
I,
or something.
yeah, I think we should have.
Let me
I
make
think
some
we should
notes
have
here.
that's probably on our end.
While we're doing
Uh,
this,
uh,
I'm going to
yeah,
make,
another thing I actually want to bring up along with this is I think one of the def IDs, the way of accessing the closure, I think there's a difference with mention when using upwards mention and closure captures is one certain places we want local IDs and certain we want the other. Let me try find the thing.
oh, okay. Sorry. I'm gonna make a little like document that we can keep up to date.
Yeah,
No,
I think that'll be good.
we kind of have one, but I'm gonna make a fresh one anyway. The ones we have a lot of stuff on them. So what I was gonna say is I think we might want to rename this to something like capture info. Yeah, so this type probably wants to be called capture map or something. And this inner map probably wants to be called like, oh, hold on, let me make a document, but I almost have it, but my computer is being awfully slow. I don't know why it's decided to creep along today. The point is, you have like the outer thing is like the closure capture map or something, and then the very innermost value is sort of capture information, right? And it's the information about a single capture. And I think it should be the upvar that we captured, at least today, and the here ID, or a representative sort of span for why we captured it. And that will evolve into a place and a span. It might be a place and a set of spans. Like, it occurs to me that I'm just thinking if you use, no, I guess that's not right. That's interesting. I was thinking that if you use, I was wondering whether there would always be a single expression that corresponds to why we captured a given place, or if there would sometimes be more than one. All right, so let's start with this. So refactor naming of upvar map. You all see what I'm typing?
Yes. Should we move this straight right in GitHub or like after so that it's just easier to keep track of?
This document?
Yeah.
We could, yeah. Either that or we'll put a link in the GitHub repo.
Okay, okay.
But usually it's good to have some, log that we can just append to every meeting. Remember what we said.
That's fair.
Yeah, I don't care. Well, we'll figure out where it lives.
All right. Okay, sorry.
So the only advantage to living here is that we can all type in it. So this type, we're going to rename. I feel like I'm watching each keystroke. It's like, okay. So I think we want this to be something like, yeah, capture maps, closure capture maps. And this would be a hash map from def ID to closure capture map singular. And a closure capture, okay, that didn't do what I expected, but that's okay. A closure map is a map from the here ID to a closure capture.
All right.
And a closure capture, I mean, yeah. Whether it should be a map or a vector, I don't know, but I'm gonna run with the map structure.
I have a suspicion it probably should be vec of pairs or something.
Yeah, I was just thinking just vec of capture, right? And like have the here ID in here.
Yeah.
Hi, Matthew, by the way.
Hi.
So this is basically the captured variable, I guess. Let's just say this and we'll see if we regret it. And then there would be like a span, I don't know, whatever there is now, an upvar ID or something. The upvar, I don't quite remember what is in the upvar ID and why are they different. They're kind of the same thing, right? The here ID and the upvar ID.
I think the here ID was like the local one, and the HR ID, the upvar ID was the path to it with some with the ID to the local thing within. Wait, let me see. I think the upvar ID just contains the closure path.
I feel like the upvar ID, my memory is that it has the pair of some pair of something.
Yeah, it's the variable path and the local def ID for the closure.
Yeah, what is it?
Yes, it's the closure expression ID. Oh, all right.
So it has the closure ID and it has this just in here ID. We have a lot of new types in this code. I think they must date from some older time when these data structures were more complicated. But okay. All right. Well, we can probably get rid of, like, upvar path is just a new type tier ID, right? Is there any reason for it to exist? I don't know, maybe. So anyway, do something like that. That seems like a separate PR to do this refactoring, right?
Yeah, we're probably going to replace that with the place in the end.
Yeah, eventually, that's what we were saying before I think we're here, but eventually this would probably go away and just become a place. And I was wondering whether we'll ever need multiple spans. I guess it depends on how we end up in the end. You could imagine, I think if you had a closure like this though, at least today we're expecting to capture A.B.C and A.B.D, but not like A.B only, because you see what I mean?
Yeah.
So I think there would always be some expression. Well, if you had these three, we would probably just capture A.B.
Yes.
But in that case, we can cite this expression as the reason why, and it's never the case that there's like no individual expression that tells you the reason why.
I think when I think even in your doc and when I was splitting up tasks, we had split this in like two separate parts where first we just get like the sort of minimal or like the maximal among the minimum work. So like we capture everything and then we try to a minimal one where we try to only get A.B out of those three. So.
Right. I think we will do it as a separate step.
Yeah.
I'm not even, I think you probably do. I mean, there's a bit of a tension where the more precise you are, the more programs type check. So we probably don't want to, except as a runtime optimization or something, capture or, like just A.B, if you see what I'm saying.
Like if it makes sense, if you're capturing A.B, then it will make sense to just only capture A.B if we also need to capture A.B.C with it. Just because it will be less things to keep track of later.
Yeah, for sure. I'm saying more if you don't have one path, if you have two paths that are not prefixes or neither one is a prefix of the other, you probably want both paths.
Yes.
Okay. All right, so that was good, I guess, but going past that, looking a little bit further on, the main thing that I started opening up some issues in this repository. about work on the here place itself. And we could discuss that a little bit. Oh, not this one. This is a very interesting one. So this is talking about whether we want to separate out the notion of a place from the location where the place is derived from, which, you know, we can do. Maybe it's not even that important because we were just saying that we're going to want to capture a span or some location in the closure where the place was used. So maybe we're going to end up wanting to capture that anyway, but I feel like it conceptually aids me at least. But the other thing is that the existing here place is not very precise, and we need to make it more precise. Does everybody on the call know what a place is?
Yeah.
Yeah, okay. So Matthew and I were chatting a bit about this, and the idea was the existing one just distinguishes deref and other, right? Which is good enough for what we needed it for at the time, but not good enough to handle this closure case. And so we were looking at what we think the place would eventually want to look at, and I think it's probably, or look like, and it's probably something like this, where you have, well, this first outer layer just distinguishes the place from the location where the place was derived from. And then the place would be a base and a list of projections. And a projection, at each point, we'll come back to this type, but the projection has different kinds, and these are the kinds. So it can either be a deref or an access to a field or some index. And we don't, here we are not, if you compare this to the mirror place, they'll see that we lost a little data, but that's because we don't think we need it. Essentially, the idea is we're only keeping as much precision as we need for what a closure might capture. And in particular, if we have a closure like this, we're sort of saying we would expect this closure to capture all of C and not just the one element of C. Not because, I don't know, it's because we usually, the borrow check usually doesn't like have that much precision, right? You wouldn't be that useful, like if we don't know what, if it was like some integer I, we can't let you use other parts of C because we don't know if they are equal to or not to this I. So in practice, that's what you get anyway.
You also had to do bounds checking, and bounds checking's kind of a nightmare to lower to mirror. So I'd rather just do it once.
Yeah, that's a good point.
Just a quick question. If I were to write let x equals C of I, will it transfer on, like not at a closure? Does that still we're still a little, not 100% familiar with Rust, but will the behavior still be the same?
You mean like?
Yeah,
yes.
Over here, will the whole ownership of C be sort of associated with, like, is the second statement incorrect then? Okay.
So, yes. So in a way, the answer is a little weird because you can't actually move out. That's another thing, is you can't actually move out of a slice, an element of a slice right now, this way. I don't think. Can you? I don't think you can. But you usually do it with like a vector with a method like pop remove or something. But if you were to borrow, for example, you would definitely get errors here because we don't know that I and J are distinct. And there might be some way to do moves through a pattern match.
Okay, yeah, as long as it's sort of consistent with what happens outside of a closure, I think, that makes sense.
I think it's consistent. We tend to lose resolution, so to speak. around slicing and indexing. Yeah, so this would be the kind of target we're reaching for. And I said I'd come back to this type. The idea here is that we store in the current here place structure. If we go back, we're storing the type of this place for the entire thing. But in this version, we kept the type at each point as we extend it. With each projection, we keep the intermediate type. And the reason is that that might be useful to us. That avoids the need to sort of recompute. In principle, we can kind of recompute those types, because if you know the starting type and you know that it's this given field, you know the type of that field, but it's some work to do and there's some annoying complications that have to do with associated types and so on that make that potentially non-trivial. So it's usually better, since we already have the type computed once, to just store it as we go, and then we can come back for it later. And the reason we might want to know the type, as an example, one reason is when we're, I'm gonna have to go in a second, but as we capture the, if you have a closure that captures a path like a.b.c, if it might be that some of these intermediate values are structs that implement drop. And if, I don't know if you all remember, but I was saying that if you have like a struct with a destructor, so it implements drop, you can't move out of its fields. So we would probably just capture a.b in a case like this, assuming that field b is of type b. And so we're going to have to do that sort of analysis where we like walk along the path and see just how much of it, what prefix of it we're actually going to capture. And for that, the types would be useful. So in order to refactor to get there, we have to take some steps. You know, there's one step of separating out this part. Like I said, that's relatively easy. I'm not sure how important it is, but we can do it. The other step would be introducing these new kinds of projections. And I talked a little bit about how the code works that creates places today, and some of the steps we might take to introduce new kinds. And I guess the other step would be changing where the type goes. So I think that's a good bit of work that we could start in on, or that some of you could start in on. So I have to run to another meeting. I only put 30 minutes here, but we can do this again next week. I think
I think.
And
yeah,
you can
I think
always
it's a good starting point.
Any
Thank you.
questions?
Yeah. Just one quick thing. So when we try call type text tables off, we need a local def ID, and is that also expected behavior? Or I would have thought that when we were using type check tables, we were using sort of a global def ID.
Yeah, that. Oh, I see. So a local def ID, yeah, that is expected. And the reason is a local def ID just means that it's the identifier of some item in the current crate that's being compiled.
Oh, okay.
Whereas a def ID without the local prefix might be some other crate like the standard library that you're depending on.
Okay, that makes sense.
We can't run type check on stuff that you're not actively compiling.
Okay, that makes sense. Thank you.
Yep.
All right.
Okay. Thanks, everybody. See you next time.
See ya.
Thanks. Bye.